Hello, this is our sixth and final video solution for the problems from Quiz 2. Here we're asked to compute a partial derivative of a function with respect to y, right? Well, the function's with respect to x and y, but the partial derivative is with respect to y. And here we're given the function explicitly, and so we're just going to use our usual rules for differentiation. Remember, the key idea when taking partial derivatives with respect to y is we treat the variable x as a constant. Okay, so if it's helpful, you could just write it as like the number 7. Okay, we're going to be treating every x we see as if it was just some number 7 or just some arbitrary constant. Okay, which means we kind of put blinders on, right, whenever we see something that's not a y. All right, well, let's give this a try. So if I want to take the partial derivative of f with respect to y, right, or equivalently notation-wise, we're going to use f sub y. Let's see, I look up and I notice I have a product of two functions, right, both functions of y, right? If one of these had just been, a square root of, say, x squared plus 1, we would have treated that entire square root as a constant. But we have a y in both of these factors, and so we're going to have to use the product rule on this. All right, so when I use the product rule, first I'll say copy this first function. So tangent 5x cubed y. So mind you, here we're using the product rule. Now I need the derivative of the second factor, and I'm going to rewrite this up here because I struggle taking derivatives when there's a square root sign or any sort of a radical, and I much prefer when we write it in exponential notation because it helps me use the power rule. All right, so when I use the power rule on this, I'm going to get 1/2 x squared plus y squared, and then I have to decrease by 1 in the exponent, so I get negative 1/2. But now I have to use the chain rule, right? I have to take the derivative of this inside function. Okay, the derivative of x squared plus y squared with respect to y. Well, the x squared is a constant, so the derivative of x squared is 0. Plus the derivative of y squared, that'll be 2y. All right, if I wanted to simplify, right, I could look ahead and say, ooh, look, I'm going to have a 2 times a half, but I'm not going to worry about that now. Okay, plus, because remember, I'm using the product rule. All right, so I need to, right, if I have fg prime, this is fg prime plus f prime g. So now I'm gonna copy this at the end, but let me first take a derivative. We need to know the derivative of tangent. Of course, the derivative of tangent is secant squared. And then I copy the input, 5x cubed y. And now I need to multiply by the derivative of this inside function, right? Because we're using the chain rule here. So product rule plus, say, the chain rule. The derivative of 5x cubed y. Well, with respect to y, this 5x cubed is just a constant. It might have just been a 7. And you know the derivative of 7y is just 7. So the derivative of 5x cubed y is 5x cubed. Okay, so that handles the derivative, and now I just get to copy the second piece, which, okay, well, I guess if I'm going to put one thing in exponential notation, I can put the other thing in exponential notation. That's fine. And there we go. We found the partial derivative with respect to y. All right, now, how would this have been different if we'd have done it with respect to x? Well, actually, you can see with respect to x, the first piece is the same. You just copy. You take the derivative in the same way, only now when you do the derivative of the inside, the y squared would have been a constant, and we would have ended up with a 2x. Okay, so if we were doing the partial with respect to x, there would have been one difference, right? Just in that first sum end. How about the second one? Well, again, this is just going to get copied down. That's the same. This first derivative, the derivative of tangent is the same. Only now, when I take the derivative of 5x cubed y, it's the y that's the constant, or really the 5y that's the constant. So I would take the derivative of x cubed, which would be 3x squared, and then multiply that by 5y. So 3 times 5 is 15. I would have gotten 15 x squared y. So actually not a huge difference in the outcome if we'd have put in a partial with respect to x.